Cut it. Hello everyone, once again I welcome you to another episode of CHM 101, Chemistry of Selected Metals and Non-Metal. In this particular video, we're working on chemistry of carbon, which happens to be the second selected non-metal. So first of all, we'll be talking about the position of carbon, the electronic configuration of carbon, the oxidation number of carbon, the production, the occurrence of carbon, allotrope of carbon, and then the compound of carbon. So let's start with the position of carbon in the periodic table. As we all know, carbon belongs to group 4 or group 14 in the periodic table. For our first 20 elements, it is group 4, while for a standard periodic table, carbon belongs to group 14 in the periodic table. Now, there's something you need to take note of. Carbon is the sixth element: hydrogen, helium, lithium, beryllium, boron, carbon. So carbon has the atomic number of 6. So if you agree with me that carbon has the atomic number of 6, that means the proton number of carbon is 6, the electron number of carbon is 6, while the neutron number here is 12, is what? Is 6, because 6 minus 6 will give us what? 6 minus 12 rather. 12 minus 6 rather will give us what? 6. So if you want to write the electronic configuration of carbon, we believe that the first share has 2 electrons, the second share has 8 electrons, third share has 8 electrons. That's the standard way of writing. So carbon has 1, 2, while for the second share of carbon has 1, 2, 3, 4. So because of this, there is a higher tendency. It's very, very difficult for carbon to lose electron. So carbon cannot lose its electron. Carbon they don't want to gain electron. So the only way carbon can be stable is going to undergo what we call sharing of electron. So when carbon share electron with other elements, other non-metal, please take note of that, they are going to form what we call a covalent bond. So that is exactly what will be formed. And as long as carbon has this electron, the electronic configuration of carbon is 1s2, 2s2, 2p what 2, and carbon undergo what we call hybridization. So it can form sp3, it can form sp2, and it can also form what? sp. So carbon actually undergo hybridization. Carbon can also undergo what we call catenation, which is the ability of a carbon atom to form a straight chain, a branch chain, or a what? A cyclic chain. So this is another very good question. What is the oxidation number of carbon? So person will say carbon has the oxidation number of +4 and -4, which is very, very wrong. Carbon exists or has 2 oxidation number. It's either it is +2 or what? Or +4. So how do you confirm this for CO and what? And CO2. So these are the 2 oxidation number of carbon. And as long as carbon atom is found in group 4, we believe that carbon is tetravalent. That's to say, it has 4 electrons in the valence share, and because of that, carbon forms a structure like this. This is how the structure of carbon looks like. So carbon has the ability to be bonded to 4 substituents for carbon atom to be stable. So one atom will be here, one atom will be here, one atom will be here, one atom will be here. So that's how the structure of carbon looks like. This is the electronic configuration of carbon. And another question that might come from this electronic configuration is that the electronic configuration of carbon has how many unpaired electrons? So please, the electronic configuration of carbon, as long as here is P2, so it has 2 what? Unpaired electron. So let's quickly go through the occurrence of carbon. Carbon exists naturally as diamond and graphite. We have impure form of carbon here as coal. As coal, please take note. So the impure form of carbon is coal, while as a combined form we have carbonate, which is, it can either be as limestone, calcium tricarbonate 4. We have magnesium tricarbonate 4. So those are the combined form of carbon. And carbon is also present in air. Remember, we believe that air is a mixture of gases. We believe that air is a mixture of gases. It consists of oxygen, nitrogen, and one of the substituents or constituents of air is what? Is CO2. So actually, we have 0.03% of CO2 in the air, in the atmosphere. So let's quickly come back to the production of carbon. So carbon can actually be formed from carbon black. For those of us who don't know carbon black, the other name for carbon black is soot. And there is one old lamp we're using then. We call it minor lamp. Or if you are using any lamp at all that requires kerosene, if you place your hand on top of the lamp, any lamp at all that requires kerosene, if you place your hand on top of the lamp for like 1 minute, that's 60 seconds. If you remove your head, I'm not saying you should touch the fire, not that you should go and touch fire. Just place your head above the flame. If you remove your hand, you are going to realize that it will be black. And if you remove, if you can easily clean the black from it, use it to touch any surface at all. The surface will become very, very black. Now that thing is called carbon black. And you can use that carbon black in the production of ink. You can also use that carbon black to do what? To produce polish. So for those of us who are complaining that you don't have money to buy polish, I've given you a way you can produce what? Polish on your own. So just place your hands on top of any lamp at all, burn the kerosene to produce your own polish. So carbon black is actually from the incomplete combustion of carbon, the incomplete combustion. So when carbon burns incompletely, what is going to form is what? A carbon black. So what about coke? Coke is also a form of carbon. All these ones say they're actually a form of carbon. So coke is actually a form of carbon that is formed from the carbonization of coal. So when you burn coal, or when coal is being exposed to heat in the absence of oxygen, the carbonization of coal, what is going to form is coke. We have coal tar, we have coal gas, and the last one there we have ammoniacal liquor. So this coke here is a fraction from the carbonization of what? Of coal. So please take note. And coke, actually we can call it carbon. Carbon black is called carbon. Soot is called what? Carbon. The other thing there is what? Is graphite. Graphite is a mixture of mica, quartz, and silicate. And graphite, as you all know, is an allotrope of what? Of carbon. Then we have another one again, activated charcoal. How do you form activated charcoal? Activated charcoal is formed from the oxidation of peat or what? Or sawdust. Then we have another one here, which is diamond. Please, the hardest substance known to man is diamond. Diamond is actually the hardest substance known to man. So if a question should come in this format, I know that a question will not even come from here. Let's say, can you use cutlass to cut diamond? No. Can you use your motor saw to cut diamond? No. The only thing that can use to cut diamond is what? Is diamond. Diamond is actually the hardest substance. There's nothing harder than diamond. It's the hardest substance known to man. And diamond has a lot of value. You can use diamond as jewelry, and I believe that most of us have not even seen what diamond is, except the one we see on television. So diamond is a very, very expensive commodity. And if you have diamond, you are rich. So I'm going to tell you how to produce your own diamond later in this video. So the next thing we'll be dealing with here is allotrope. Carbon actually have two allotropes. So what is allotropy? Allotropy is the ability of an element to exist in two or more various forms in the same physical state. So in that same physical state, carbon actually have two allotropes, which is carbon can exist in a crystalline form and a non-crystalline form. The other name for non-crystalline is called amorphous. So if you hear the word amorphous carbon, the other name for it is what? Non-crystalline. And please, crystalline stands for shape. Something that has shape, while non-crystalline stand for what? Doesn't have shape. So please take note of this. And we have two crystalline form of carbon. Is either is a diamond or a what? A graphite. While for the non-crystalline, it can be a coal, it can be a coke, it can be charcoal, it can be lamp black, which is also known as soot. This lamp black, please take note. You can call it lamp black, you can call it carbon black, you can also call it what? Soot. So these three names is just for one thing, and that's what I've explained earlier. Then we have sugar charcoal, we have animal charcoal. So please, how do you form sugar charcoal? I can say sugar charcoal is more of burning, combustion of sugar in the absence of air. When you burn sugar in the absence of air, let me give you something. For example, we have C6H12O6. This is sugar. So when you remove water from it, 6 molecules of water, that is how many hydrogen here? Oxygen here is also 6. So at the end of the day, we are going to have 6 carbon. So we call this what? A sugar what? Charcoal. So the dehydration of sugar is going to produce sugar charcoal. Then animal charcoal, we have wood charcoal. We have wood charcoal, we have animal charcoal. Now, animal charcoal, when you heat animal in the absence of oxygen, or bones in the absence of oxygen, absence of air, you are going to form animal charcoal. Same goes to what? To wood charcoal. All these ones here, they are non-crystalline what? Carbon. For example, someone is telling you that charcoal, what is the shape of charcoal? You can't give a shape of charcoal, but you can give a shape of diamond. You can give a shape of what? Diamond is usually uh, uh, octahedral, while graphite is what? Is hexagonal. So let's quickly move to compound of carbon. We have oxide of carbon, which can be carbon 2 oxide, or what? Carbon 4 what? Oxide. This one is carbon 4 oxide, while this one is carbon 2 oxide. We have carbonate of carbon. For example, magnesium carbonate 4, that is in dolomite. Calcium carbonate 4, which is in limestone. So those are compound of carbon. Then we have another one again, carbide. For example, we have CaC. So this CaC is called calcium what? Carbide. So we have a lot of things to actually discuss about carbon. We can't go deeper than this, because if you move a step further, we are going to enter organic chemistry. Carbon atom is carbon is actually very broad. Carbon is very broad. And like what I do say, there is no element in the periodic table that have more compound than carbon. Carbon has millions of compound, billions of compound. There's all the elements, in fact, all the elements in the periodic table, if you combine their compound together, is not up to that of carbon. So carbon produces lot of elements. And without carbon, there is no human. So that's to say, in your body there is carbon. In fact, there is that thing which we call organic chemistry. It's a branch of chemistry that studied just carbon. So organic chemistry deals with the study of living things. Let me use that. So every living thing you see, plant or animal, whatever that is living, has what? Carbon. So you know that carbon uses, we have a lot of uses of carbon. I can't even list them. There are more, there are too many. Like I've given you one already, other diamond, carbon black I've given you, coke is there, graphite is there, activated charcoal is there. All of them, they have different uses, various uses. Magnesium carbonate 4 is there, dolomite, which is a limestone is there, production of cement. So the use of carbon is all limited. You can't count them. It's all limited. So that's why in this video we'll not be working on the uses of carbon. So that's everything about the chemistry of carbon. I have a question for you. Carbon undergo dash kind of bonding. Option A, we have electrovalent. Option B, we have covalent. Let me just leave the two. Does carbon undergo covalent bonding or electrovalent? Please take note. The other name for electrovalent bonding is ionic bond. If you have any question based on what I have explained so far, please feel free to drop that in the comment section. Goodbye.